Okay, number 1, we're going to break down the 27. So 3 times 9, 9 is 3 times 3. We're looking for a cube root, so I'm looking for a group of 3. So I have a group of, or a set of 3 3s, so I pull a 3 out on the outside. And then you have 9 x's here, so you can either write out all 9 x's and then group them. So there's a group of 3, a group of 3, and a group of 3. So I pull 3 out. Or you can do the division. So we can say 3 goes into 9 3 times, so I pull out 3 x's. Number 2, you're just rewriting with exponents, so it becomes 4 to the 3/5. The inside number goes on top, the outside number goes on the bottom. Number 3 is the same way, it would be 3 to the 6/11. Number 4, you're going backwards, so we put the 4 on the inside. The top number is the exponent, so the 5, and then this is the 2. So that's radical form. Then it says simplify, so you can just put this in your calculator. This is a square root. So I can just say square root of 4 to the 5th, and I get 32. So 2-step problem there, write in radical form and simplify. Number 5, let's break down 24. So 4 and 6. So I have a group of 2 2s, so I have a 2 on the outside and a 6 on the inside. Make sure that you multiply these, you don't add them. Then for the x's, there's a 2 here, so I say 2 goes into 5 twice, so that's 2 x's on the outside, and my remainder is 1, so 1 x on the inside. And then for the y's, 2 goes into 4 twice, so I have 2 y's on the outside. So 2x squared y squared, square root of 6x. Number 6, 8 times 10. So be careful here, looking for a group of 3. So there's 1, 2, 3, so I can pull a 2 out on the outside, and then the 2 times the 5 stays on the inside, so 10. For the x's, 3 goes into 4 once, so I pull 1x on the outside, and my remainder is 1, so 1 on the inside. And then for the y's, 3 goes into 9 3 times, so I can pull out 3 y's, nothing left over. Number 7, first I would divide 54 by 2, so cube root of 27x to the 6th, and then break it down. So I have a group of 3, so I pull a 3 on the outside, and then 3 goes into 6 twice, nothing left over, so I have 2 x's on the outside. Number 8, first thing you do is pull out the I, so it becomes 5i square root 40, and then break up the 40. 4 times 10, 2 times 2, 2 times 5. So I have a pair of 2's, those can come out and I multiply it with the 5, so 10i, and then this 2 and this 5 have to stay on the inside, so 10i square root 10. Number 9, break up the 75, 3 times 25, 5 times 5. So I have a group of 5's, and multiply it with the 7. So 7 times 5 is 35. This 3 is the only thing left on the inside. Number 10. So first thing you do is pull out the I here and here. So this will be 3i square root 2 minus 4i square root 8. And then you can't combine these until the radicals are exactly the same. So if I break down the 8 here, I have a pair of 2's. So this stays the same, 3i square root 2 minus, if I pull a 2 out, make sure you multiply it here with this 4i. So minus 8i square root 2, because that 2's left. Now I can combine the front numbers. 3i minus 8i, negative 5i square root 2. 11 is similar. First thing you want to do is take out the i's. So 3i square root 32 plus 2i. Now I'm bringing an I out and I already have an I there, so that's I squared. So 3i square root 32. I squared is negative 1, so it changes this to a negative 2 square root 50. So break down 32 into 8 times 4. I'm looking for a group of 2's. There's a group, and there's a group. So 2 times 2 is 4. Multiply it with the 3. So 12i. This 2's left on the inside. Break down the 50. So 5 times negative 2 is negative 10, and this 2 is left on the inside. Now, even though these are both square root of 2's, I can't combine the front numbers because this one has an I and this one doesn't. So this is your answer. Number 12, distribute the negative. So 3 plus 7i minus 5 minus 2i, and then just combine like terms. 3 minus 5 is negative 2. 7i minus 2i is 5i. And 13, just combine like terms. 3 plus 2 is 5. 5i minus 6i is negative 1i. Number 7, we're going to multiply outsides together. So 3 times, or not 7, 14. 3 times 6 is 18. And then 5 times 24 is 120. And that stays on the inside of the square root. So now we break down the square root of 120. So 12 times 10. So we have a group of 2's here. Everything else stays on the inside because it doesn't have a pair. So 18 times 2 is 36. And then I have 3 times 2 times 5 is 30. Number 15. Take out the i's before you do anything. So 2i squared, square root 18, times 4i squared, square root 5. Oops, I squared. I squared turns into negative 1, so it makes this a negative 2 square root 18 and a negative 4 square root 5. Now it's the same as 14. Multiply outsides together. Negative 2 times negative 4 is 8. And multiply insides together, which is 90. So this is 9 times 10, 3 times 3. So we have a group of 3's. 8 times 3 is 24, and I have a 10 left on the inside. Number 16, 5 times 5 is 25, plus 5i, minus 5i, minus I squared. These middle ones cancel. Then I get 25 minus I squared is negative 1. So then that changes to a positive 1, which is 26. 17, 2 times 3 is 6. 2 times negative 2i is negative 4i. Plus 15i minus 10i squared. Don't forget the squared. So this becomes 6 plus 11i. I squared is negative 1, so it makes this a positive 10. So 6 plus 10 is 16 plus 11i. Number 18, multiply root 2 over root 2. And now just multiply across the top. So 9 times 2 is 18, and it stays under the radical. Root 2 times root 2 is root 4, or just 2. So now I want to simplify just the 18. 3 times 6, I have a group of 3's. So 3 root 2, the 2 stays on the inside, over 2. And nothing can simplify, so this is our answer. Number 19, multiply by 5, change the sign here, plus root 3 over 5 plus root 3. So distribute across the top. 20 plus 4 root 3 over, multiply across the bottom. 5 times 5 is 25. Negative root 3 times root 3 is negative 3. On here, you don't have to multiply everything out because these are conjugates, so I just did the shortcut. 5 times 5, negative root 3 times root 3. So 20 plus 4 root 3 over 22. And then everything can be reduced by 2. So 10, 2, and 11. So 10 plus 2 root 3 over 11 would be our answer. Number 20, we have to multiply by negative 5i over negative 5i, so distribute. So negative 15i plus 5i squared over negative 25i squared. So that becomes negative 15 I minus 5 over positive 25. Everything can be reduced by a 5, so 3, 1, and 5. Negative 3i minus 1 over 5. And 21, multiply by 2 plus 7i over 2 plus 7i. So this one you have to distribute across the whole top. So 4 plus 14i plus 14i plus 49i squared over, and the bottom you can do the shortcut. 2 times 2 is 4. Negative 7i times 7i is negative 49i squared. 4 plus 28i minus 49 over 4 plus 49.
So half the test is overall.
So negative 45 plus 28i over 50.
Does that make sense? Did we do a problem?
53. Okay, determine the value of I. So on this, you need to know these. So remember the pattern repeats in groups of 4, so we're going to take that number and divide it by 4. So I get 21.25. 21 times 4 is 84. So when I split it up, I get 84, and then there's 1 left over to get to 85. So then that's my answer. Either the first is just I. So same thing here, 146 divided by 4 is 36.5. 36 times 4 is 144. So I go I to the 144, and then I've got 2 left over. So I squared is negative 1. 24, 251 divided by 4 is 62.75. 62 times 4 is 248. So there's 3 left over. So since I have I cubed, my answer is negative I. And the last one, 47 divided by 4 is 11.75. 11 times 4 is 44. 3 left over. So negative I again. All right, number 26. First thing we want to do is subtract the 8 over to get the square root by itself. So square root 2x plus 10 equals 6. And then to get rid of a square root, we're going to square both sides. So on the left, 2x plus 10 equals 36. And then solve for x. So subtract 10. 2x equals 26. And divide by 2. So x equals 13. Okay, on number 27, the square root's already by itself, so we could just go ahead and square both sides. So 2x minus 8 equals 36. Add 8. 2x equals 44. And divide by 2. So x equals 22. Remember, you can always take your answer choice and plug it into the equation to see if it works or not, especially on a multiple choice test. Number 28. Divide by negative 3.
Right, so 105.
So cube root of 7y plus 4 equals 2. And instead of squaring both sides, we're going to cube both sides now because of the 3. So on the left, we get 7y plus 4. On the right, this is 2 cubed, which is 8. Subtract 4 and divide by 7. And number 29, square both sides. So on the left, x plus 33. On the right, you have to write out x plus 3 times x plus 3. So multiply out the left, x squared plus 6x plus 9. Move everything over to the left. So 0 equals x squared plus 5x minus 24. And we're just solving for x. So I would factor. And when you solve for x, you get -8 and +3. Now on this one, especially when you get the two answers, make sure you plug them back into the original equation, because when you plug in -8, it does not work. So only +3 is a correct answer choice. Okay, number 30, we'll graph 2x squared minus 4x minus 3. So first thing, it's in standard form, and it has a minimum. So let's find the vertex. Second trace, number 3. So a little bit to the left. Oh, shoot. A little bit to the right. And guess. So 1, -5 is the vertex. So the axis of symmetry is x equals 1. There's a minimum value at -5. The y-intercept, second trace value, put in 0. So 0, -3. Domain is all real numbers, and the range is the lowest y value up to the highest y value. All right, number 31, we want to graph it. I'm going to rewrite it. So the 0 is on the left, so I could put x squared plus x minus 6. And we're going to say that it is greater than. So graph that. So it looks like it's, let's see the table here. +2 and -3. 1, 2, 3. Sorry, I put in a greater than, but it should be a less than. There we go. Okay, so we're at -3 and +2. So shade around. So our solution set would be x is less than -3 and x is greater than 2. Okay, number 32 to 35 you can solve by any method you want. So you can use factoring or quadratic formula or completing the square. It doesn't matter. So on number 32, since there's only two terms, I'm going to take out a GCF of 3b. So we're left with b minus 7. And I can split that up. 3b equals 0. b minus 7 equals 0. So divide by 3. b equals 0. And on this one, add 7. So b equals 7. 33 looks really gross, so I'm going to go with quadratic formula. So x equals negative b, which is -8, plus or minus the square root, b squared minus 4ac all over 2a. So x equals 8 plus or minus square root of 388 over 6. And let's see if I can simplify that 388 at all. It looks like it breaks up into 4 times 97. So that would be x equals 8 plus or minus 2 square root 97 over 6, and then I can take a 2 out of all of those. So x equals 4 plus or minus square root 97 over 3. Oh, that's ugly. Okay, number 34. I'm going to take a 2 out of everything first. And this one looks like it's easy to factor, so I'm going to factor this one. C plus 11 and c minus 2. So if I split that up, c plus 11 equals 0, so I get -11. And c minus 2 equals 0, so I get positive 2. And the last one, 35, let's see if I can factor it. 42, 1 and 42, 2 and 21. 3 and 14. 4 doesn't go in. 5, 6, and 7, 8, 9, 10. So none of those will add up to 12. So it doesn't factor, so I'm going to use quadratic formula. X equals negative, sorry about my handwriting, negative 12 plus or minus square root b squared minus 4ac all over 2a. So x equals 12 plus or minus square root of negative 24 over 2. So this becomes 12 plus or minus I square root 24 over 2, which would be 2 square root 6. And everything simplifies by 2. So this is a 6, a 1, and a 1. So we get 6 plus or minus root 6. And the last one, what number should be added to both sides of the equation to complete the square? So we're going to use our little formula, b divided by 2 squared. So we take negative 12 divided by 2, which would be negative 6. So we would get 36. Remember, it's always positive because this is negative 6 times negative 6, which is a positive.